Okay guys, so what we're going to be doing today is we're going to be looking at secant lines and average rates of change. Um, this is, I don't know, a pretty good topic, I guess. I think we're not going to have too much algebra in here. I think it's mostly going to be kind of conceptual stuff that you'll have a good time with. But we'll see. So what is a secant line and what is an average rate of change? That's what we want to know. So let's look at secant lines. Secant line. Okay, that's an A-N-T, by the way. My writing, hard to read. Okay, so let's draw a picture here. We need a function. So draw a perfectly straight line, like that. And we need a curve. So let's just have a curve. There's a curve. Probably shouldn't have drawn it so it looks vertically, so I'm going to change it a little bit. Okay, now it's not vertical, right? Now, what is an average rate of change? I just decided I didn't like it at all, so I'm redrawing it. Let's try this. That's nicer. Don't try to make it complicated. Okay, so what is a secant line? So a secant line is going to be as follows. So a secant line is a line. Okay, good job. That goes through 2 points on a graph, 2 points on a curve. Like so. So if I put a point here, and I put a point here, and then I just basically connect the dots with a straight line. How do I do this? Draw a straight line, connect the dots. Can I move that endpoint? No. Once it's down, it's down. Okay, so let's just say that that goes through those 2 points. Okay, that's a secant line. Secant line. Okay, now probably in this section we're going to be looking at slopes of secant lines, and we may be looking at equations of secant lines. But regardless, first we'll be looking at slopes. So you need to know what is the slope of a secant line. So of course you know in general what a slope is, right, of a line. So slope of a line is generally y2 minus y1 over x2 minus x1, right? That would be if you have coordinates of one point called like x2, y2, and the coordinates of the other point were x1, y1, right? So x1, y1, x2, y2, and then you would have a slope like that. However, on a lot of these, you're going to have your functions as being called like y equals f of x. And in that case, just draw a different one here. I'm drawing a different shape, it doesn't matter. F of x like that. If I want to put a secant line on here, I'm going to put it here and here. Again, those are 2 points. There's nothing special about it going through 0. Like that. There we go. There's another secant line, right? Secant line. Secant. And right nicer. Secant line. Okay. Now, if this curve has the equation y equals f of x, then you might call these points a little bit differently. Maybe you call this point b for the x value, and the y value could be f of b. And maybe this one over here, maybe the x value is a, and then the y value would be f of a, right? Because you would have to calculate the y value from that x value. So this would be at a here, and I guess that would be b. So if your line goes through points, let's see, um, through points, a f of a and b f of b, erase that, b f of b, what would the slope be, right? The slope would be, in this case, it's the same formula as above, right? But it would be f of b minus f of a would be my y2 minus y1, and my x2 minus x1 would be b minus a. Okay, so that's how you would get the slope of a secant line. And then another thing that they do in this section right away is they define the average rate of change of a function basically with this same formula that we've got right here. Okay, so I want to write a definition. Definition. The average rate of change of f of x over a to b. So you can say over a to b, or you can say from x equals a to x equals b. Both of those are okay ways to say that. So the average rate of change of f of x over a to b, or from x equals a to x equals b, is given by a in the formula. I just write like average rate of change, ARC, but it doesn't matter what you call it. And what would the formula be? It's the same formula as above. So it's f of b minus f of a over b minus a. Same formula. Okay, so what have we learned so far? What we've learned is that the average rate of change and the slope of a secant line are really the exact same thing in terms of how you calculate them. Okay, so that's important. So average rate of change from, let's see, a to b. I'm not going to write x equals. I'm just going to say from a to b. Average rate of change from a to b is the same thing as the slope of the secant line. So the slope of the secant line between 2 points, a f of a and b f of b. All right, so regardless of whether they're asking you for a slope of a secant line or the average rate of change, you're going to be calculating the exact same thing. Just y2 minus y1 over x2 minus x1 with whatever the problem is for your specific problem. So yeah, so let's do an example now. So given the graph, which I'll give you, given the graph below, determine the average rate of change from x equals minus 5 to x equals 1. Okay? And yeah, so let's do that. So I'm going to draw the picture here, and then once we have the picture, then we're going to actually be able to solve the problem. So picture looks about like this. We're going to go, we need to go out to -5. So let's say -1, -2, -3, -4, -5. Keeps going up to 4. and up this way must be 1, 2, 3. And then up this way, how far do we need to go up here? Looks like at least 6. So, all right, so we've got to count these as blocks of 1. 1, 2, 3, 4, 5, 6, 7, 8. That'll be enough. All right, so this curve happens to go through not very many points, like specifically. So goes through that one. Do I see any more that it goes through? Yeah, looks like -2, +5. Goes through that one. At 0, it's a little bit less than 4, so about there. At 1, looks like 3, so about there. At 2, it looks like about 2, 2, so about there. All right, so I just need to draw a curve that goes through this, and that will be our curve. So our curve is going to be like that. Okay, so that's our curve, and that's going to be y equals f of x. All right, so how do you do this problem? Well, you're going to start with the formula. So by the way, up here I wrote it this way, ARC for average rate of change. Looking at the homework for you guys, I see that the homework uses this symbol, M secant. So M is what we normally do to indicate a slope, and SEC for secant line, right? So slope of the secant line is what they're saying there. And again, the formula is going to be just a y2 minus y1 over an x2 minus x1. And you just need to know what y values you're looking at. So at 1, we're there, right? Because that's x equals 1. And then we have x equals -5, which is over here. And so we need those coordinates. So you figure out where this point is. It looks like -5, +6. And you need the coordinates here, which looks like 1, 3. And then you just plug in the numbers here, and you're going to get an answer. So, like y2 minus y1. Which one's y2, which one's y1? Doesn't matter as long as you're consistent. So if I call this one 1 and this one 2, right? 0.1, 0.2, then y2 minus y1 is going to be this y value minus this y value. So you're going to go 3 minus 6. And then for the x values, x2, oops, that's not what I wanted. For the x values, you're going to want this one minus this one. So that's going to be 1 minus -5. So you get 3 minus 6 on top, which is -3. And on the bottom, you get 1 minus -5, which is +6. So overall, we've got -1/2. Okay? So we've got an answer. So we're done with the problem. But want to be really clear here. You know, what are we calculating? We are calculating the slope of this line. Okay? So the slope of the line through those 2 points, slope is -1/2. Okay? So that's what you're calculating when you calculate an average rate of change, is that kind of slope. But then this is the answer to the question. Okay, so we're going to be doing this probably a bunch of times, and that's going to be this homework assignment. Okay, but you're not always going to have numbers. So something that they're going to do, because it's going to be relevant in the next section in particular, is they're going to give you a problem where instead of having 2 points to plug in numbers here, one of the points has variables, and you're just going to have to work it out. So here's what that looks like. Example. Find the average rate of change, so same problem. average rate of change of f of x from x equals 3, that's fine, to x equals t. So that's the new thing, right? That's not a number, that's a variable. And then of course we have to have a function. This time they're not going to give us a graph, they're just going to tell us what the function is. So f of x is negative 5x squared plus 3x minus 1. Okay, so that's what we need to do now, is find that average rate of change. Now that's where you're going to want to have the other formula in mind, right? You're going to want to have this formula, why can't I draw? This formula in mind. F of b minus f of a over b minus a. Okay, so again, we can still call it MSEC because that's what they are calling it, but it doesn't matter. There it is. What is it? It's f of b minus f of a over b minus a. Well, what are the b and the a, right? Make sure you understand from the formula here, right? When they say from x equals a to x equals b, right? The first x value is a and the second x value is b. Okay, so this must be our b, t, and this must be our a in the formula. So you go ahead and fill this out, take a couple of lines, don't try to rush it and make a mistake. So f of b, we're putting a t into the function. Well, actually, let's do it in multiple steps, right? I just said do it in multiple steps, and then I was going to try to do too much. So if you fill in our numbers, right, we got b equals t and a equals 3. Then we have f of b, which is t, minus f of a, which is 3, over in the denominator, t minus 3, right, b minus a. So then from there, you can substitute in what is f of t, what is f of 3. And that's where I'm going to need a big fraction here. So f of t. F of t is plugging the t into the formula for f. So f of t is negative 5t squared plus 3t minus 1 minus f of 3. F of 3 is plugging 3 into the formula. So negative 5 3 squared plus 3 minus 1. And then that's all over t minus 3. Okay, so let us work out what we have here. Now, in this first part, there's nothing to be done. Just leave that the way it is. However, in the second part, where the 3 is plugged in, you can work that out. It's going to be a number, right? So you've got 3 squared is 9. 9 times 5 is 45. So that's negative 45 plus 9 minus 1. So what does that work out to? So that's negative 46 plus 9. Oh, I can't do that. What are we doing? Let's see here. Yeah, negative 46 plus 9. Negative 37? Is that right? I feel like that's right. Over t minus 3, like that. And from there, you should combine your like terms. So you have a minus minus 37. So that's a plus 37. But you can combine that then with the negative 1. So you have the negative 1 and the 37. Negative 1 plus 37, which is going to be 36, positive 36. So you have 5t squared plus 3t plus 36 all over t minus 3. Okay, and I'm going to type this into the computer just to see if they want us to do the algebra on here. And I'm going to show you the algebra anyway, but I just want to double check how they want it, so I can tell you. Yeah, okay. So you can type this in, and this is correct, okay? So this would be accepted as a correct answer, but you should simplify it more, okay? Accepted as correct, but you should simplify, okay? Because you're going to need to real soon. So the question is, how do you simplify that, right? And the way you would simplify that is you would try to factor, okay? So to simplify, try to factor the numerator. Okay, and you can. It's a little bit tricky to factor. I'm going to go to a computer in a minute, but before I do, I am going to factor it by hand just to show you how I would do it. So when you're doing this, like you're trying to factor like a squared plus b, sorry, when you're trying to factor ax squared plus bx plus c, what you do is you should multiply the a and the c together, and then you should not multiply, you have the b down there, and put those in this little picture here, and then do something. So let me do that. So what's 5 times 36? Okay, I don't know what that is, but well, let's figure it out actually, because we need to. So 5 times 30 is 150, and then 5 times 6 is 30, so I think that's 180. So I think it's 180 up here, negative. And then in the denominator we have b, which is 3. Okay? And what we're supposed to be trying to come up with here is going to be numbers that multiply to negative 180 and add up to 3. Okay? So we want to add up to negative 180. Sorry, I said it right the first time, and then I just wrote it weird there, backwards. So we want numbers that multiply to negative 180 and add to 3. Okay, so that tells you a lot, really, because you're looking for numbers that multiply to 180, and there's not a lot of them that are going to do that. So, I mean, it'll be tough, but let's see if we can do it. So, let's see. 15 times 12. Those are different by 3, right? How big is that? Wait, do we already have them for some reason? How did we get the 180? What did we multiply to get 180? Oh, 5 and 36. Okay, so it's not those. What goes into 180 anyway? I don't know. Let's think here. It's not 9 and 12. Well, you can do it this way. They have to differ by 3 in order to make it add up to 3. So just take numbers that are different by 3. So what's 10 times 13? Right, that's 130. Well, that's too small. What's 11 times 14? That is 154, I think. So it's not that. What is 12 times 15? What is that? I don't know. Is that it, actually? Hold on. I need a calculator. All right, let's just go to a computer or a calculator. 12 times 15. 12 times 15. 1, 2 times 1, 5. It is, okay, 180. Okay, so that was it the whole time. I dropped my pen. Where'd it go? Okay, got it back. So, get closer to the microphone. Back here. All right, so it was 12 and 15 is 180, okay? And so we should put 12 and 12 and 15 is 180, like that. They need to add up to positive 3, so this one should be negative, and 15 should be positive, and then we'll get negative 180 when we multiply and positive 3 when we add. So you have those. So then that tells you that when you've got negative 5t squared plus 3t plus 36, you can split the middle term into a positive 15x, or in this case, a positive 15t, because we got t's, and a minus 12t plus 36, right? So you see, we had 3t, and we just split it up this way. Still adds up to 3t, so it's correct. But that's what we did. We split the middle term. Then you group the first two terms and the second two terms, and you factor out what you can. So on the first two, you can factor out negative 5t, and you'll be left with, looks like t minus 3. Yes. And on the second one, you can factor out a minus 12, and you'll be left with, it looks like, t minus 3. And then there you can factor out a t minus 3, and you'll be left with negative 5t minus 12. Minus 12. Okay? So that's it. We factored it. So let's go back to where we were. We had our answer up here, but now we can say our answer is going to be t minus 3 minus 5t minus 12 over t minus 3. And look at that. You know, you've got some canceling here. This cancels with this. And you'll be left with a new answer, which is just negative 5t minus 12. And that's your answer. Okay? Now, you should be able to do this, right? Because if this was on a test or something like a real test, you would have to do this without anybody helping you, right? Now, you're doing this on a computer because this is an online class, which means what you could do is you could go here and we go to wolframalpha.com, and we should just be able to type in like negative 5t squared, what was the middle term, plus 3t, plus 3t plus 36 divided by whatever it was, which was t minus 3, like so, and we should just be able to have the computer do this for us, which it will somewhere there. Quotient and remainder. Interesting. Okay, right there, yeah. So it should just be input, result, right? So negative 5t minus 12. And feel free to do that. Although, like I said, you don't actually have to do that on the homework. The homework will let you put in the unsimplified version. Back here. Okay, so again, this first answer works. The second answer is better, okay? Because you're going to have to do that at some point in this class anyway. But there you go. So that's how you do that. Now, that's probably the hardest stuff in this section. Now, another thing you're going to have to do is you're going to have to do the same thing using tables of data. So same type of question here. So let's see, find average rate of change. Average rate of change. This one's going to have numbers. So from x equals minus 7 to x equals minus 1. But then rather than giving you a function or a graph, what they're going to do is they're just going to give you a table of values. So they're just going to go like negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. The table keeps going, but that's as far as I'm going to do it. These should all be straight lines, but it takes longer to draw a straight line, so I'm not. And then we got some numbers down here. So 16, 27, 33, 40, 51, 59, 64, 71, 81, 90, 98. Okay, good enough. Okay, so this is the problem, right? And we want, well, what it says, right? Average rate of change from 7 to -1. So again, they use this symbol for it. So what we're looking for, right, is just like y2 minus y1 over x2 minus x1, and we're looking for specific x values. So x equals -7, x equals -1. So you just find them on here, right? Here's the -7, and here's the -1. Only thing to be careful about here is that you get the same point in the same place, right? So if this is your like x2, y2, then make sure you know that you put it in the first spot in the formula, both times, top and bottom. All right, so y2 minus y1. So y2 would be 81 in this case. Y1 would be 33. And then for the x values, we would have -1 for x2 and -7 for x1. Okay? And what do we get? Well, you just work it out. So 81 minus 33. So what is 81 minus 33? 48? I think so. Okay. And then -1 minus -7 is -1 plus 7. So that's 6, positive 6. So then you have 48 over 6, which is 8. And that's your average rate of change. Okay. Just going to type this in to the computer and verify that this is correct. Yes. Okay. All right, now something I'm going to do here is I'm going to give you an alternate formula for the average rate of change, just because the book does, or the homework does here too, and you know, it's good to see both formulas. Okay, so going to a picture here, so this is just an alternate formula. For two things that can be calculated the same way. You can use an A and a B, and you have a point, and you have another point, and then the slope between them, right? I'll just say M, like they do. M SEC is, we know f of B minus f of A over B minus A. That's the formula we know. However, we could use this formula. So we're calculating the same thing here. So like the same type of graph, let's put A there, let's put B there. Again, it doesn't have to match perfect. And you still have a slope there. So connect those 2 points. And there's still going to be an M secant. But what they do is this. Rather than call this B, which I just did call it B, but instead we're going to say, let's just call it A plus H. Because if A is here, right, if this distance, if you just say that this distance is H, then you've got A and A plus H for your X values. And if you plug these two things in to the formula, then you're going to get this formula. So an alternate formula for the slope here, slash average rate, is M secant equals, and you just plug those two things in, A and A plus H, for B and A, right? So this is your B. B is A plus H. So you have F of A plus H minus F of A over A plus H minus A, which is F of A plus H minus F of A over H. Okay, now again, this is just an alternate formula. It doesn't actually give you anything that the other one doesn't give you, but, well, the book uses this one sometimes. And there are reasons why we're going to use it later, so we may as well just start using it right now. So let's do a problem with that one. So this is going to be a lot like the one that we just did, but I'm going to use this alternate formula here. So given f of x equals negative x squared plus 5x minus 1. That's not the same one, is it? No, because we have 5 this time. Almost the same problem. Given that, find the average rate of change from x equals 3 to x equals t. Okay, and I'm just going to use the alternate formula this time just because. So m secant, it's going to be this one now, f of a plus h minus f of a over hold on here. You know what? I'm going to write this like this. But even though the book gives this formula here, this is actually not going to work very well for this problem. So this is a perfectly fine formula. However, for this problem, it's a terrible formula, and you should stick with this anyway, is what I'm realizing as I'm thinking about it. So that is a good formula. It is a bad formula for this problem. Anyway, so let's just do this real quick. It's the same as the previous one. So we're going to be putting in what for what? Well, we've got, what's our b? That's our b, right? So that's that. And then what's our a? Our a is 3. A is 3. And I should have changed this as well back to b minus a. So put the a's in the right place, put the b's in the right place, and then we'll do this problem. Okay, so let's do it. So b is t, so you have f of t minus f of 3 over t minus 3. We need to evaluate those using the given formula for the function. So that's negative t squared plus 5t minus 1 minus f of a, which is negative 3 squared plus 5 times 3 minus 1 over t minus 3. So you work this out. Just leave the first part alone for now, pretty much. For the second part, we want to get a number. So we've got, what do we have? Negative 9 plus 15 minus 1. So that's 15 minus 10. So that's 5 over t minus 3. And we get negative t squared plus 5t, looks like minus 6, isn't it? Over t minus 3. Now, again, you can factor this, okay? I'm going to do this the quick way, rather than factoring this. So this is negative t squared plus 5t minus 6. Let's come back here. Negative t squared, was it plus 5t? Plus 5t minus 6. It was a plus? Let's find out. Okay. So they say 2 minus t. 2 minus t. Right? So that's what it looks like if you are using your computer resources to help you calculate this in a efficient way. Right? This would have been accepted by the computer though. Okay? Better. All right. So see what else do we have in here. Yeah. Let's go back and do another one that's actually numbers. So let's try this. And after this one, I'm going to check if there's anything that we haven't seen. And if there is, we're going to do it. And if there's not, then I think we're just about done here. We've seen the types of problems that they have. So here's a function. And we want, you'll never guess, average rate of change from -3, x equals -3, I should say, x equals -3 to x equals +3. All right, so this one's nice because we actually have two numbers this time, right? Two numbers means we don't have any factoring or anything to do here. So what you're going to do here is simply slope of the secant line, f of b minus f of a over b minus a, and you're going to, for your a and your b, there's your a, there's your b, 3 and -3. So this is f of 3 minus f of -3 over 3 minus -3. So you just plug these in. F of 3 is going to be 3 squared minus 3 plus 1 minus f of 3, or sorry, f of -3 is going to be 3 minus 3 squared minus -3 plus 1 over 3 minus -3 is 6. Okay? So you work this out. We should be able to get numbers here. So we have 3 times 3 squared is 27 minus 3 plus 1. So, and then this over here is going to be 3 times -3. So -3 squared is 9. 9 times 3 is 27 minus -3. So that's going to be +3 plus 1. So what do we get here? This first one is 27 minus 3 is 24. 24 plus 1 is 25. Minus, this one is 27 plus 3 is 30. 30 plus 1 is 31. So we have this, 25 minus 31 over 6, which is -6 over 6, which is -1. And you get a number, right? So on the last problem, we got a function here because we had this variable as our b, right? Up here, we have a variable for b. This one, where a and b are both numbers, we just get a number for our answer, and that's easy enough. And we're done. Okay? Now, I'm just going to stall for time for a second here while I check these problems and make sure there's nothing weird or new. Nope. It's all good. Okay, so that's that is homework 9, secant lines and average rates of change. So we got more videos coming, but that is it for this one. See you next time.